Okay, so we've discussed the nature of quadratic roots and we've discussed how to solve a cubic. What I want to talk to you about over the next few minutes is the nature of cubic roots, or just the different combinations of roots that we could have in a cubic. As we worked out in the previous video, every cubic has 3 roots and there are no exceptions to that. However, not every cubic has 3 real roots. So let's look at the different possibilities for cubic curves. Okay, so the first possibility is the most obvious one, and it's the one that we dealt with in every question in the previous video. If a cubic has 3 real distinct roots, that implies that it crosses the x-axis 3 times. So I've drawn a plus x cubed and a minus x cubed, and both of them cross the x-axis 3 times. When we are finished the Leave Insert Higher Level course, it'll be relatively easy for us to identify the maximum point and the minimum point of a curve. One way of proving that a cubic has 3 real distinct roots is if the maximum point is above the x-axis and the minimum point is below the x-axis. If it's above the x-axis and below the x-axis, it has to cross the x-axis 3 times. In this one, the minimum point is below while the maximum point is above it. So when we have finished the course, we will be able to do that. However, that's not incorporated in the algebra. Using algebra, we're not able to get the maximum point and the minimum point. So in this video, we have to come up with another way of proving that a cubic has 3 real distinct roots. The second scenario is you could have a cubic that has 3 real roots, 2 of which are equal. So first of all, I drew myself a plus x cubed, which might look like this. If 2 of the roots are equal, that means that it has a turning point on the x-axis. So this one, it still has 3 roots. There's one of them, and there's 2 of them at this point. So it has 3 real roots, but 2 of them are the same. If I had a minus x cubed, it might look like this. It crosses the x-axis here, and it has 2 roots at this point as well. So that's the second scenario where you have a cubic that it still has 3 real roots, but 2 of them are the same. Okay, and then the third scenario we can come across is a cubic equation or a cubic curve that has only 1 real root. Or another way of writing it is 1 real root and 2 imaginary roots. For example, let's have a look at this one. This one is a plus x cubed. It still has 3 roots, but 2 of them are imaginary roots. So it is 1 real root and 2 imaginary roots. The other scenario is, all I've drawn here is a minus x cubed, and in this case it crosses the x-axis once, and then it has 2 other imaginary roots. So that's the other scenario for if you're dealing with a cubic. Once again, I want you to notice what the characteristics of the turning points here. In both of these, the maximum point and the minimum point is on the same side of the x-axis. If a cubic only has 1 real root, the max and the min will either both be above the x-axis, or the maximum and the minimum point will both be below the x-axis. Now, to be honest, that's not really that important for us yet. That becomes important when we study differentiation later on in the course, but I just want you to have just thought about it when we're dealing with the algebra. What we need to do in this video is we need to figure out if you're given a cubic, how can you prove that a cubic only has 1 real root? Or how can you prove that a cubic has 3 real roots? And all of the theory, we've already actually covered all of the maths for this. All we need to look at is what we did in the previous video and what we did in the video on the nature of quadratic roots. So supposing I was given something like this, where I'm asked to prove that this cubic has only 1 real root. If a cubic has only 1 real root, that means 1 of them is real and 2 of them are imaginary. Every cubic has 3 roots, it's just that not all of them are real. So if I'm asked to prove this, I'm just going to start my question off the same way as we start any question. I'm just going to try and solve this cubic. If I need to solve a cubic, the first thing I need to do is use trial and error to identify the first root. So logically, the first thing we always try is x equals 1. If I sub in 1 into this, if 1 is a root, that means everything will cancel. So I would get 1 cubed minus 5 times 1 squared plus 17 times 1 minus 13 equals 0. And if I simplify this down, I'll just get 1 minus 5 plus 17 minus 13 equals 0. 1 and 17 is 18, minus 5 minus 13 is minus 18 equals 0. Clearly my constants are going to cancel each other out there and I get 0 equals 0. So I'm happy enough with that. Clearly I can now conclude that x equals 1 is a root. But the only reason that's useful is because if x equals 1 is a root, I can convert that into its corresponding factor. So I can conclude that x minus 1 is a factor of the cubic. And we're still going to treat this question just as if we've been asked to solve it. If x minus 1 is a factor of the cubic, I'm going to divide x minus 1 into this cubic, and it's going to give me the other factor. So I'm sure after the previous video you're comfortable with your long division, but I want to drag this one out nonetheless. The first thing I would do is divide x into x cubed, and I would get x squared. The second thing I'll do is multiply x squared by each of these, and I'll get x cubed minus x squared. My third step is to subtract, so I draw a line underneath this and change my signs. So I get minus x cubed plus x squared. The x cubes will cancel, and I have minus 5x squared plus 1x squared, and that gives me minus 4x squared. And my fourth step then is to take down the next term, which in this case is a plus 17x. And now I'm just going to start my process all over again. I want to divide x into minus 4x squared. So that's going to give me minus 4x. Then I want to multiply minus 4x by each of these. Minus 4x by x is minus 4x squared. Minus 4x by minus 1 gives me plus 4x. I'm going to draw a line underneath, and I'm going to change my signs. So this becomes a plus and this becomes a minus. My x squareds will cancel, and I have 17x minus 4x, which is 13x. And I'll take down my next term, which is a minus 13. And I'll start my process all over again. Divide x into 13x, and it gives me plus 13. And I'll multiply 13 by each of these, and I'll get 13x minus 13. I'll change my signs and subtract, and everything cancels, and my remainder is 0. So I've confirmed that x minus 1 is in fact a factor of the cubic. And that's given me the other factor, x squared minus 4x plus 13. Now this is where things get a little bit different. I now know that the factors of the cubic are x minus 1 times this quadratic. In previous videos, what we've done at this stage is we've factorized and solved this quadratic. However, you're not going to be able to factorize this quadratic, and if you use the minus b formula, you're not going to be able to solve it either, because this quadratic has complex roots, or in other words, imaginary roots. So you're not using algebra, it's impossible for us to actually solve this. Let's look back at what the question asked me to do. It asked me to prove that this cubic has only one real root. The very first thing that I did was I proved that x equals 1 is a root. That's 1 is a real number, so that's the root. We know the real root is x equals 1. So what I need to do is I need to prove that the other two roots are imaginary. In other words, I need to prove that the two roots of this quadratic are imaginary. Cast your mind back to the video we did on the nature of quadratic roots. We were dealing with the discriminant. If the discriminant b squared minus 4ac is less than 0, then a quadratic equation has no real roots. So in order to prove that this cubic has only one real root, we found the first real root, and now we're going to prove that the quadratic has no real roots, or in other words, it has two imaginary roots. And then I'll be able to conclude that x equals 1 is a real root, and then that this quadratic has two imaginary roots that are they're the roots of this cubic. So we started off with this as our original cubic, and we've deduced that the factors of the cubic are x minus 1 times this quadratic. X minus 1 is standard enough, you can let it equal to 0, and your real root is x equals 1. But what I need to do is to prove that the other two roots of this cubic are not real, or that they're imaginary. So I need to prove that the roots of the quadratic are not real. In order to prove that a quadratic has no real roots, or in other words, two imaginary roots, you need to prove that the discriminant is less than 0. Just think your minus b formula here. A is the coefficient of x squared, which in this case is 1. B is the coefficient of x, which in this case is minus 4. And c is the constant at the end, which is a 13. And all I need to do is simply sub into this. B squared becomes minus 4 squared minus 4 times 1 times 13 is less than 0. Minus 4 squared is 16. Minus 4 by 13 gives me minus 52 is less than 0. 16 minus 52 gives me minus 36 is less than 0. Clearly that one is true. B squared minus 4ac is less than 0 for this quadratic. So I can conclude that this quadratic has no real roots. So here there's two imaginary roots, whereas here there's one real root. So the original cubic we got has one real root and two complex or imaginary roots. So I think it's important, there's a lot there. Again, the maths is straightforward and we're not actually doing any new maths, but as you can see yourself, the theory on the cubics can get very involved. Okay, so to practice that material, I want you to try just two questions. In each case, I'm giving you a cubic equation and I want you to prove that the cubic you're given has only one real root. So I want you to pause the video now, I want you to try these two questions and then compare it to my solutions. The first question you had here was to prove that this cubic has only one real root. In order to do that, we need to use trial and error to find the first root. So I subbed in x equals 1 and I ended up with minus 5 equals 0, which obviously it's not, so that one's not true. Then I subbed in x equals minus 1 and I ended up with minus 51 equals 0, so that one's not a root either. The third one I tried then was x equals 2. When I subbed in x equals 2, I ended up with 0 equals 0. So that one is the right one. We can say that x equals 2 is a root, and then we convert that into its corresponding factor. We can say that x minus 2 is a factor. Once I have that factor, I'm now going to use a long division to divide x minus 2 into the original cubic to find the other factor. So it's fairly basic long division here. I've divided x minus 2 into my original cubic, and I ended up with x squared minus 6x plus 10. And now what I need to do is to prove that this quadratic has no real roots. If this quadratic has no real roots, and I've already identified the one real root, that is x equals 2, I can conclude that the original cubic has one real root of x equals 2 and two imaginary roots that come from this quadratic. So I started off with this is my original cubic, and I know two factors are x minus 2 times this quadratic. If I let this factor equal to 0, I find the only real root, that is x equals 2. I need to prove that the other two roots are imaginary, so I take this quadratic, and to prove that a quadratic has no real roots or imaginary roots, I need to prove that the discriminant is less than 0. The discriminant is b squared minus 4ac. And in this scenario, the a will be the coefficient of x squared, which is 1, b is the number in front of x, which is minus 6, and c is the constant at the end, which is a 10. So if I simply sub into the discriminant, I end up with 36 minus 40, which gives me minus 4 is less than 0. And clearly that is true, minus 4 is a negative number, so I can conclude that this quadratic has no real roots. And then ultimately the whole thing shows that the cubic has one real root and two imaginary roots. And that's what I was trying to prove. The second question here, you needed to prove that this cubic has only one real root. So it's the same as the previous ones. We have to start with trial and error to find the real root. So we investigate first if x equals 1 is a root. You sub it in and you end up with 0 equals 0. So happy enough with that one. We can conclude that x equals 1 is a root, and by extension x minus 1 is a factor. Once you've one of the factors, you simply divide x minus 1 into the original cubic to find the other factor. So I've taken my factor and I've divided it into my cubic and got a remainder of 0, which verifies that x minus 1 is a factor and x equals 1 is a root. But the more importantly, it's given me my other factor. I also know that x squared minus 14x plus 53 is a factor of this cubic. Now I look to the question where I was asked to prove that the cubic has only one real root, which I found at the very start is x equals 1. So now I need to prove that this quadratic has two imaginary roots, or in other words, no real roots at all. Okay, so I started off with this cubic and I've worked out that two of the factors are x minus 1 times this quadratic. If I take this factor, I find a real root, which is x equals 1. And I take this factor, I need to prove that it has no real roots. In order to prove that a quadratic has no real roots, I need to prove the discriminant is less than 0. In this case, a, b and c are 1, minus 14 and 53 respectively. So if I sub them into my discriminant, I end up with minus 16. Clearly minus 16 is less than 0, it's a negative number, so I can conclude that this quadratic has no real roots, and by extension the original cubic has one real root and two imaginary roots. So that's all we need to do for question 2 here.